So what two tools did we discuss last time? Yes.
MIRR.
MIR is one of them,
And,
which should give you the clue. IRR?
yeah.
Yep. So what is IRR, Chris?
The internal rate of return.
Okay, so what are we looking for when we solve that?
A percentage.
Okay, a percent. The percent of rainfall in Ohio? What are we looking for? Percent of what?
Who's it about?
Nathan?
Like return generated, like off of like the like your investments or outflows or whatever.
From the project that's being evaluated, okay? Compared to its original investment, right? So it's all, that's right, internal. It's how much the project is returning on its original investment, like the size to start the project. So, what are some of the benefits? None? No. Chris?
Easy management.
Easy to manage?
Easy management.
Okay. So management is, can remember just, the cost of capital. Remember, that's how we're gonna make a decision. We're gonna compare the IRR to the cost of capital. So it's really easy for management, board of directors, to remember the cost of capital. And then when they get presented with a project, it's easy for them to, quickly see if it's going to be good or not good. Yeah. What are some problems with IRR? Yes?
You can get like multiple like answers or it overstates like either positively or negatively.
Yes, so there's two separate problems. One is that we get multiple answers, which we really don't like. And the second is that it overstates the results. Why does it overstate the results? Yes?
Because
Nathan has it today.
it assumes the reinvestment's at the IRR and not the cost of capital.
Exactly. Right, the cost of capital is the best reinvestment assumption. And when we looked at NPV and profitability index, we did use the cost of capital. But for IRR, it uses the IRR rate as the reinvestment assumption. So that is creating an overstatement of the results. So our solution to that was the MIRR. Okay? So it's a little more complicated, but it takes care of both of those problems. It's still a rate. It's still comparing it to the original investment. We still make the decision by comparing the IRR to the cost of capital. Okay. So, on all fronts, it's a winner there. Any questions about IRR or MIRR? Okay, so that, what? Okay, must have been something happening there. So today, we're talking about how do we compare projects if they have different lives. We need terms, that's what I mean by life. We need to adjust it to make them comparable or similar. So if we don't do that, then our evaluation, a direct comparison, is actually meaningless and might be misleading. So longer-lived projects almost always have higher NPVs, but that doesn't mean that we always want to choose the longer project, right? If you could accomplish something in 1 year, or you could take 10 years to do it, well, it's very likely that you'd prefer to do it in 1 year. Even if you run an NPV analysis and say that 10 years is higher NPV, because we're not taking into account all those years there. So we're going to learn 2 methods. I'm going to describe them briefly, and then we're going to go in and learn more about them. The first is called the replacement chain method. And basically it says that we can repeat a project as often as we need to in our assumption so that we can have them of equal life. So in the example I just gave, we have a 10-year project and we have a 1-year project, so we would repeat that 1-year project 10 times. Now we can more directly compare them. It's really weird. The second method is called the equivalent annual annuity method, or EAA. Equivalent, right? The same as. We know an annuity is a regular payment at a regular interval. And in this case, it's an annual annuity, and so that time period is annual. Basically, we're going to replace each project with an equivalent payment that equates to the project's original NPV. Then we can just compare those 2 payments. So a stream of cash flows. Remember when we talked, I think it was back in chapter 6, about time value of money, and we said you could pay X amount at the beginning, you could wait for 7 years and get that much at the end, or you could have so much difference over time. All of those have the same NPV. So that's what we're doing here. We're going to find the NPV for that whole stream of cash flows and find a payment that is an annuity payment rather than whatever the payments were for the project. We'll work through some examples. So, replacement chain method. To compare a 2-year project and a 5-year project, common life is 10 years. We'd repeat the 2-year project 5 times and the 5-year project twice. Now we have 10 years. So we assume that the project's characteristics, their cost, cash flows term, can be infinitely repeated. So then we can find the NPV and move on, determine which is best. If you have your supplemental pages, we spent a lot of time talking about Mr. Chen, but if you turn it over, you will see a problem with Sergei Borevsky's glassware. He is considering the replacement of an old, fully depreciated blow furnace. Okay, so on his books, it has 0 value, right? But he's still using it. 2 new models are available. The Supreme, which has a cost of $190,000, a 3-year expected life, and after-tax cash flows for labor savings and depreciation of $87,000 per year. The other potential is a deluxe. It has a cost of $360,000. It has a 6-year life and after-tax cash flows of $98,300 per year. Blow furnace prices are not expected to rise because inflation will be offset by cheaper components used in the machines. That is a simplifying assumption for us. Assume that glassware's cost of capital is 14%. Should the firm replace its old blow furnace, and if so, which new furnace should it choose? Okay, so here's the setup. Any questions on that? Okay, so if you look at that, for replacement chain method, you can see that the Supreme is 3 years and the Deluxe is 6 years. So what is the lowest common life term? 6 years, right? So in order to do that, we assume replacement of the Supreme. Now, be careful here. You have to buy the machine at the beginning of the project. This one lasts 3 years, so you have to buy that machine here. Sometimes students want to put it out in year 4. Well, what are you going to do during this year when you don't have a blow furnace, right? So be careful of that. So he's buying one, and then he's assuming he's going to buy another for evaluation purposes there, right? So we find the NPV for each alternative. So what is the N, let's split this up. This side of the room, find the N, well, you know what, we better do this all together. Find, because there's a trick in there, and I want everybody to beware of what's happening here. So find the NPV for the Supreme. And you will probably want to use your cash flow register. I'm sorry?
So, we put the 190 in.
You would not times the 190 by 2.
That's what I thought.
You want to have the cash flows at each time period.
Okay.
That one occurs at time period 3.
So you add that on to, okay.
Yes. Okay, who has an answer? Do you have an answer, Ruth? You can just go to NPV if you don't have 32. Do you have an answer?
No, I keep getting an error 4 when I put in the, negative 103 for the third cash flow.
Well, you don't have any cash flow first.
I should, but. Oh, I can,
Oh, that's probably why.
yeah, hold on, sorry.
Okay, okay.
Maybe wrong.
No. Oh goodness, okay. Did you put it? Okay, that's for just one. Okay, and you didn't extend it. I'll have to put it in those Okay, so CFO needs to be negative 190. Then 87, actually you can just do twice, right? You don't have to put each separate one in. So there's 87, 2 times sequential. Then we have negative 103. I think everybody got that. So 87 in minus the 190 out. That happens once. Then we have 87 3 times. And that's all you need to put in. And then that the interest is 14%. Okay? Anybody have? No, that's the other cup, I guess it's Alex. Okay, so 20,069. Is that what we ended up with? Oh, I thought you had a lot of stuff in there. Okay.
Every time you gotta do this, it keeps asking for the interest rate again.
Did you press MPV, and enter, and then the down arrow?
Oh,
And then computer.
oh, okay.
Yeah.
Right. 20, 2060.
Okay, so go ahead and calculate the NPV for the deluxe.
Hmm. I did, 360.
Okay.
Okay. 3 for 6 years.
Okay, and did you check? 'Cause I
Oh,
think there's
it's
stuff in there.
Oh, I should. I hate that sometimes. I was like,
Yes.
there's no way I'm doing it.
No, 6.
You have a,
Yeah. I was like, yeah.
I put it, but I don't think it calculated for me.
Okay. Yes. yes.
And then just hit compute.
Well, go to NPV. Okay, that's right. Now compute.
This is.
Yep.
Oh, okay.
There
Thank
it
you.
is. Okay. So, y'all were in this mode, and that was fine. So 360, and then 98.3, 6 times. Because the 98.3 is an annuity and doesn't change, you could have used your time value keys. Okay? No one did, but you could have, and you would get the same answer. Right? If you said what N is 6, I is 14, payment 98.3, future value 0, you would get present value 22,256. Okay. And looking at that, okay, this is twice as much. It's going for longer, so we would expect that this might be more, but we always have to check. And we did, right? So the NPV of the Supreme is 20,069, and the NPV of the Deluxe is 22,256. Okay. Given this information, what do you recommend for Mr. Borevsky? To buy the Supreme, to buy the Deluxe, or to do nothing?
Buy the deluxe.
Buy the Deluxe. Why is that?
You have higher value.
Right, it has higher value. It will bring more value to the company. Now recognize, we're essentially comparing it. What would be the NPV of his current furnace?
0.
0. Okay, so that's not saying it has no value, but in comparison, it's 0, that the Supreme will bring in 20,069 more than the current furnace, and the Deluxe will bring in 22,256 more than the current furnace. Okay. So why might he choose to do nothing?
If they were both losing value, then we'd wanna not do either project.
Okay, that's a possibility.
I think the upfront like capital he would need to like buy the equipment, like the 360 and the 190. If he didn't have that, like or couldn't finance that out, like he wouldn't do it.
Yeah, I mean, if he's successful, he could probably go to the bank and get it.
Yeah.
But that's a lot of money. And if he is running a really small business, he might not want to take that risk. My current blow furnace is doing its job. It's worth it to me to wait to put out that big capital expenditure. Even though on a present value basis, it would be better, right? He would have more. But all we're looking at here is that overall expense. And the 14% should capture the risk, right? It's supposed to be a risk-adjusted cost of capital. But as a small business person, still might want to just not be laying out all that money. And especially if he does have to borrow, then he's paying interest. And that's a fixed cost there. So from a financial perspective, we would recommend that he buy the Deluxe. But we need to understand why he may not want to do that. Okay, any questions on the replacement chain method? Can you see any drawbacks to this?
Like, what if the time is long? And
What if the time is long? Absolutely. Okay. What else? What if you're evaluating 7 projects? this begins to get quite complicated. You can do it on a spreadsheet, but it's a mess. So the second method gets away from those concerns. As I mentioned, equivalent annual annuity. Equivalent is the same as, an annuity is a regular payment at a regular interval, and annual. So we are looking at 1 year periods for those annuity payments. So the goal of this method is to find an annuity payment such that the present value of the payments equals the present value of the project's total cash flows. Okay. So we're going to calculate the NPV of each project, which we already have because it didn't change, and then find the equivalent payment with the same cost of capital. Okay. So now, when we are looking at the Supreme, we do not need a second time period. We can just look at each project as it stands. Okay? So what is the project for the what is the project? What is the NPV for the Supreme project considering 3 years, the full, just the project itself without replacement?
Well, that's good.
Sorry, Nathan. Okay, very good. 11,982. And again, you could have done it either with your cash flow register or with your time value keys. Okay. Now we need to take that present value and find an equivalent annual payment, assuming nothing up front. Okay. So what would N be? 3. I? 14. Present value? It's going to be 11,982. Okay. We're looking for the payment. What's the future value? 0. Okay. So what do you find for an equivalent payment? Did you get one?
Yeah. 5,161.
5,161. Is that what you got, Sydney? Whatever you put in, it will come out the opposite of compute. Yeah. You don't have to re-enter everything. Okay, 5,161. So what does this mean essentially? So here was the original, and here we found the NPV. They paid 190 up front to get 3 years of 87,000. The equivalent payment, nothing up front, and 5,161 every year. Right? This is the equivalent to this cash flow. Okay? So this is not what's happening, but this is the equivalent NPV, so we can use this to compare and analyze. Does that make sense, Smith? Chris? Connor? Sydney? T? Great. Maisie, how about you? She's recording. Okay, then we're going to do the same thing with Sergei Borovsky's glassware. Now, we did this already because we did the replacement chain. So the NPV was 22,256. So now find an equivalent payment for that NPV. Good. Everybody got the right answer. Excellent. 5,723. Again, this cash flow of negative 360 and 6 years of 98,300 have the same NPV as if you paid nothing up front and received 5,723 every year. It's the equivalent payment for that NPV over the time frame of the investment. Okay? We should end up with the same answer no matter which method we use. So we said the EAA for the Supreme was 5,161. So the Deluxe gives a higher EAA. Just like we had a higher NPV, even though it's for 6 years, right? And Supreme was for 3 years. So this is why EAA is so powerful, because we can calculate the NPV just for the project as it stands, and then directly compare the EAAs, because it's the same every year. You could test this by taking the NPV for the Supreme for 6 years and calculating the EAA, and you would find it's the same EAA that we calculated for 3 years. So we can directly compare whatever that EAA is, and that would tell us, because we want the highest EAA, right, what we should do. Any questions on this method?
So, like the NPV is higher for the deluxe, or yeah, for the deluxe one. So, would the EAA just be? It wouldn't always be like that.
It wouldn't always because
The time.
of the time frame. That's why we have to convert it to the EAA. So the EAA and the replacement chain method will give you the same priority. EAA is much better, easier, right? And works when you, like if you still had 59 projects, that would still be relatively easy.
Right. Okay.
I would resign if I were to replace and chain for that many. But this is the whole reason we have to do something like this, because a higher NPV for projects with different time frames is not going to give you the right answer necessarily.
That's how we can compare with each other. Right?
Exactly.
So like on a test, if with a question like this, could we use either method since they will give us the same answer, or?
Well, I might say, use the replacement chain method, or I might say, just do it and you figure out what you want to do. If you don't have two projects to compare, right, you can always find the EAA on a project. But replacement chain doesn't make sense unless you're comparing them. Other questions at all? Okay, so you feel pretty confident with replacement chain and equivalent annual annuity method and why we're doing that? So the why and the how, I guess. Did you have a question there, Connor?
No, I'm just kind of thinking about it. So, like, say a company only had like one project to choose from, and they had to make it last 6 years, and they only could find like, I know it's like kind of unrealistic, but like, if they only had like one project to choose from, but they needed to make it last 6 years, then they would have to replace it. Like, would we have to use replacement? Like, I know that probably won't happen, but I'm just thinking, like.
If a company only has one option to solve their problem, then they probably have to do that.
Okay, you wouldn't need to calculate.
If a company has a project that is expected to last 6 years and they have to make a decision, should they buy machine A or machine B, I think they still can go through this exercise, because if the Supreme is the better machine, it makes sense to assume that you're going to replace it halfway through, because that's better than buying a 6-year machine.
Got it.
Yeah. That's why a lot of companies that have a lot of sales, they will get a new car for their salespeople every year or two, because it's just worth it, even though you know that the car, realistically could last maybe 5 or 6 or 20 years. You don't want your salesman driving around a 15-year-old car that might go broke someplace.
Yeah.
Okay. Then our next little topic we want to talk about is capital rationing. So this almost always happens because companies, just like individuals, rarely have enough money to do everything they would like to do. So generally you rank the projects in descending order, the MIRR, and you cut off at the cost of capital, just like we did the other day. This doesn't always make the best use of capital, so a complex mathematical process called constrained maximization can be used, but we're not learning that. If you've ever heard of linear programming, that is useful as well. Constrained maximization is similar to linear programming. I had the joy of doing that in my stats class in college. She says sarcastically. Okay, so this is similar to what we looked at the other day. Here is the rate, here is the cost. Each project is laid out with the amount of capital that it will use. So if C is not, in order to do C, you have to raise more capital, because here's your limitation. So if it's not good to raise capital at that point, then maybe you don't do C, but actually you do D, right? Because then D slides over and can be accomplished there. So you put them in priority order, but when looking at the overall, right, it might be that D is better there. Okay. It's really just the idea, it's a pretty straightforward idea, that there's not enough money to go around and you need to prioritize. And how do we do that? MIRR is a good way. NPV, we said, is the best rule, but if you're looking at projects with different lives, we just learned that would not be the best. We'd want to look at EAA, which is rooted in NPV. Right? That would also be very good. Okay, that is all I have from that book, but I was going through and realized that in my advanced class, we actually do this capital budgeting review. So this is just so important. We do it all the time. So what are some, we're going to go through this pretty quick because the last few chapters that we've been working on pull this all together. So the goal for capital budgeting is to help the company decide from a financial perspective whether or not to invest in the project. We said that there were 3 types of projects, right? Replacement projects, expansion projects, and new venture projects. And we learned how to calculate the cash flows for those different projects. And then we make a decision using all those decision tools, either if it's a standalone project or mutually exclusive. So what were those tools? The payback period, the time to recover the early cash outflows, right? How long until the project's revenues exceed the initial investment? Basically, you just subtract or divide if it's an annuity, right? If it's within the policy period, we accept it. If not, we reject it. So it's really easy to calculate, it's easy to understand, but it does not consider time value of money. The policy period is arbitrary, and it doesn't consider the cash flows after the policy period. So then we had the discounted payback period, which was similar, except the cash flows are considered on a present value basis. So it's better because it takes care of the time value of money, but it's still an arbitrary policy period, and it still does not consider cash flows after the policy period. So we get to NPV, our very favorite. We look at the project's cash flows discounted at the cost of capital, and we compare that to the cash outflows. If it's positive, we accept the project. If it's negative, we don't, because that would say it's destroying value to the company. There really aren't too many negatives. The big pro is that it relates the value of the project to the value of the company. And it is the single best indicator, and as we learned, the reinvestment assumption is the cost of capital, which is great. The profitability index is related to NPV, but it's a ratio. The present value of the inflows over the present value of the outflows. So a PI of 1 says that we're just at break even on a present value basis. So we want the PI to be greater than 1. Okay? So we looked at IRR, the return the project generates on the investment of the cash flows, right? It's the percentage return on the investment. That's what we said. We said that with the investment that you have to make to buy the cash flows is the price of those, and it's the interest rate at which, right, the inflows equal the outflows, and therefore, right, with IRR, the NPV is 0, and so we accept a project if the IRR is greater than the cost of capital, and we reject it if it's less. We talked about the pros and cons earlier in this class, but there are some significant problems. So then we have the MIRR, which helps us to resolve the issues from the IRR. We're still solving through a rate, but the big thing to remember here is each cash flow is going to be used once in the evaluation. If it's negative, we do a present value, and if it's positive, we do a future value. Okay? And then we find that terminal value, the future value, and solve for the rate. Okay? Because we have found the future value and the present value using the cost of capital, that is the reinvestment assumption. Okay? And we only have one negative and one positive number, so we only have one answer. Okay? But we're still looking for a rate, and we're still going to compare that to the cost of capital. So when we look at these tools, the IRR, MIRR, PI, and NPV should give us the same accept reject decision. They might give us different priority decisions, but they'll give us the same, right? You should not have, for example, a positive NPV and an IRR that's less than the cost of capital. Something has gone wrong. So this just walks through the methodology, finding the present value of the cash inflows, the future value of the cash outflows, and then setting them equal and finding, oh, I'm missing a little N down there on the MIRR. Here's working through one. Let's see. Oh, 3-step process. Remember, we're going to find the cash flows by what happens at the beginning of the project, what happens over time, and what happens at the end of the project. Okay? And then what to include. We worked through that list. Most of all was to think. We do not include sunk costs or financing costs. And then we talked about makers. Okay, that's about it. Any questions on any of that or comments? Right. So Monday we will work through a more comprehensive problem. I meant to hand it out, but I didn't get it done. And review, and then you have some time, because that's our last class day. It's pretty amazing. Zippity quick.
How accumulative will the test be?
How cumulative? It will be quite cumulative. Hard to ask you to calculate NPV if you don't know time value of money.
Are you gonna do like the cash flow statement or something like that?
No, there will be no cash flow statement.
We're allowed to use our computers though for like Excel, right?
Not your computer, no. I know. Yep, in this case, you're gonna have to just think about the layout of things. So the material, I'll go through this again on Monday, but the material that has not been covered on a test yet will be about 50% of the exam, and overall will be about 50%. So it's a little more weighted to the end. Yeah. But really, there's so much of the original stuff that shows up at the end. Okay, enjoy.